Yes, sir. കാണാൻ പറ്റുന്നുണ്ട്.
Right. Thank you.
Yes, now it's
Visible. Right. So we had stopped at this point, say flow control. We had explained something more also. Simple protocol we saw. So we are discussing data link layer functions, and we saw flow control. We're discussing flow control, and we saw simple protocol where there is no flow control or error control. Then we went to stop and wait protocol where each frame is sent and an acknowledgement is expected, and we saw that there is something called as CRC, cyclic redundancy code, which is to detect errors. We'll see about CRC later in this topic itself, error detection part. Then so acknowledgement, and say this diagram also we saw this one. So how the stop and wait protocol is doing. So it is sending a frame, waiting for an acknowledgement, and so it sends a frame, turns on the timer. So before the frame is also buffered, and then it waits for an acknowledgement. If the acknowledgement arrives, it's everything is fine. Here the frame has been received correctly. Now one thing to remember about this data link layer is that a data link layer is concerned with delivery of message or whatever the frame on a same network. It's related to the physical address, same network or two entities. It will be much more appropriate to say two entities which are connected by two nodes which are connected by a physical link. It could be the nodes could be part of the same network, or it could be a node in a network and a router. That means we saw this link like this. We saw a figure like this earlier. Say, so this is a network and it is connecting to its router. That can also be possible. So the data link layer operates at that stage. So the flow control, all those strategies are applied to this. Whereas at much higher level, you have the transport layer. The transport layer does this flow control over the entire what do you say, delivery, the globally. Okay, so that is the difference between these two strategies. So transport layer, say for most protocols, this flow control is rarely implemented in the data link layer. Rather it is dealt in the transport layer, but data link layer does have a role in this flow control. So for academic interest as well as what do you say, better understanding of the topic, we are dealing with this thing. So this is stop and wait protocol, and then you have this case of duplicated frames. I think we discussed those things last day. So the lecture is there on the YouTube link. You can follow that. Now without losing time, we'll go to this. We discussed this as well. Say, I'll just explain this here. The frames are sent by the data link layer from the transmitter to the receiver. So it sends a frame. These frames as well as acknowledgements, they are having sequence numbers. So it sends a frame with the sequence number 0 and it is received correctly. So the data link layer of the receiver will send an acknowledgement frame with the sequence number 1. Indicating 1 indicates that the next frame expected should have a sequence number 1. So the sequence number in the acknowledgement indicates the sequence number of the frame which this data link layer, the receiver data link layer, expects next. Now here in this case the frame 1 is lost. So it say what happens, lost means there is a timeout. It doesn't get an acknowledgement with a sequence number 0, so it will again resend this frame and it receives that acknowledgement within the timer before the timer times out. So that is the way in which again the next frame that is to be sent is frame 0. The acknowledgement is lost, frame 0 is again resent, but the data link layer understands that I am expecting a frame with the sequence number 1. I am getting a frame with the sequence number 0. That means it's a duplicate frame. So I'll discard that frame I am receiving again. So duplication is prevented. So this is a very good approach, but the drawback with this approach is that it's a half duplex arrangement. At a given time only either the sender or a receiver can communicate. It's a half duplex arrangement. There is another alternative which is being called as piggybacking. Piggybacking is a process where piggybacking, P-I-G-G-Y-B-A-C-K-I-N-G. Piggybacking is an arrangement where you can add this acknowledgement also to the frame, which acknowledgement in a frame that goes in this particular direction. So it will get a free ride on this frame. Similarly, if there is a, so you can make it, so you can conserve some resources. So you can send this acknowledgement along with the data that is going in this direction. So that is piggybacking. That's the way you say you get a lift, same manner. You take a lift by a vehicle, something like that way. So same manner you can have a piggybacking arrangement, but on the whole this is an inefficient use of resources. And an alternative that strategy is sliding window protocol. So sliding window protocol is an alternative arrangement where the sender and receiver, they have some agreement as to the number of frames that can be sent, data frames that can be sent. So and only after sending this many frames I'll send an acknowledgement. That is what, how it happens. Even before the communication proceeds, actual communication starts, there will be some sort of handshake signal, some sort of communication. Say you will agree, suppose you are standing in a chain like manner and handing over, say this, say for instance you are in this flood relief time and all. There were a lot of students who were involved in this relief operations. They were in the relief material collection centers. So the people were unloading things from the lorries and all those things. They were passing these packets one by one. So they have an agreement that at one point only I'll send one parcel to you, so that it can be handled easily. But if someone violates that, sends two things, then the entire chain might get disrupted. Everyone is prepared for one packet at a time. So same way the sender and receiver have an agreement. So and there are two ways in which this sliding window protocol, two variants of sliding window protocol. This sliding window protocol, actually you don't have such a thing in the data link layer, but rather in the transport layer. But we'll see how it works here using some figures. So there are something called as in go back and ARQ, automatic repeat request, that is ARQ. ARQ is automatic repeat request, and also selective repeat ARQ. The terms itself clarify what this mean. So we'll see this go back and ARQ. This is very simple. So the sender and the receiver, they have agreed that, say this is the I'll be sending 3 frames, and then say I'll send 2 frames, and then I expect an acknowledgement. That is what the understanding is. So at the sending and sending side as well as the receiving side buffer, you will have some sort of if you observe the protocol, you will say that there is some sort of window like thing that is moving, that is corresponding to the number of frames the sender and the receiver can transmit, and then transmit as sender can transmit and the receiver can receive, and then it can be acknowledged. So it is sliding through this the sequence numbers, that's what you can say. So I'll send 2 frames, then I'll get an acknowledgement. Then again, if it works properly, so there is an agreement. So it can be a variable thing as well. So here the sender is sending frame 0, frame 1, then the receiver is sending an acknowledgement with a frame with the sequence number 2, indicating that I'm expecting a frame with next frame with the sequence number 2. So it sends the frame with the sequence number 2, and so it will advance the receiving window by 1 step. So I have got it correctly, and it sends out an acknowledgement with the frame, what do you say, sequence number 3. And again it gets this acknowledgement. So it says I need to send the next frame. So 0, 1, 2, 3, that is the sequence numbers here in this. Sender side and the receiver side is also 0, 1, 2, 3. So I'll send the frame 3. Okay, I got the frame 3 correctly. So I'll send a sequence ACK0. ACK0 means I'll send the sender will send the next frame with the sequence number 0. So the same process happens. So they can agree as to how many frames that can be at a given time transmitted, and then an acknowledgement can be received. So you can reduce the number of acknowledgements. Say you needn't acknowledge for each and every frame. Rather, you can acknowledge it for 3 frames or 2 frames at a stretch. So that is the assumption. So this is, and what happens is that if by any chance there is there is a lost frame or lost acknowledgement, all those situations, you needn't transmit, you can go back to the retransmitting the entire n frames. That is what go back n. Say here frame 0 is sent, frame 1 is sent, and I am sending an acknowledgement back from the receiver, indicating that the next frame that is expected is with the sequence number 2, and promptly the sender will send the frame with the sequence number 2, but unfortunately it is lost. So what happens? The receiver will understand that receiver will discard, that is this frame. It's not receiving it. It's not. So, and what happens? Again the next frame is sent, nothing happens. So the receiver will discard all these frames. This frame is discarded, and it is expecting the frame with sequence number 2. That is what. And then it will send the acknowledgement 3. So that way the communication is synchronized. So this is a very more practical way of doing that. So and if a block of frames is lost, means you will retransmit from that point. So I'll just summarize this thing. You will send the sequence frames in a sequence and receives acknowledgement. So when an error is detected, the receiver will discard that frame. So frame 2 was expected here in this case, but it received frame 3. Frame 2 was lost. So it will discard frame 3, and it will inform the sender. Inform the sender is not indicated here in this. So it already knows that it has got an acknowledgement up to 2. So that is understood. So sender will resend the entire data sequence starting from that frame. So suppose there are 5 frames in 5 sequence numbers 0, 1, 2, 3, 4, and at the after the second frame is transmitted, second frame is lost, that is frame with the sequence number 2 is lost, then and you have went on to transmit 3 as well as 4. What is done is that it is understood that the frame 2 has been lost, so it will again begin transmitting from frame 2, 3, 4 onwards. So go back n frames. So from the point where it is lost, it will retransmit all the remaining frames. So it will sender begins resending the data sequence starting from that frame. So even if the sender has transmitted the frames 3, 4 and 5, if the sender understands that the frame 2 has been lost, it will again retransmit the frame 2, 3, 4 as well as 5. So that is go back n frames. So ARQ is referring to automatic repeat request. So this is much more efficient way of doing this. So than the stop and wait protocol. More data is being transferred. You are reducing the acknowledgement to be reducing the number of acknowledgements. But the only drawback is that you are again bringing in inefficiency, because the frames, in our case, the frames 3, 4 and 5 were received correctly, but still because of this protocol of go back n, what happens, all these valid frames also had to be retransmitted. So that is an issue. To prevent this thing, you have an alternative which is called a selective repeat. Only the frame that is lost, that is repeated. And here in this case, you will have the concept of NAK, negative acknowledgement. So negative acknowledgement. So as usual, the frames 0 and 1 are being transmitted. It is received correctly, and acknowledgement 2 is sent. So the next frame is 2, but it is lost. So the receiver just sends the frame 3. The sender will say NAK2. I did not receive the negative acknowledgement. I did not receive the frame 2 correctly. So please resend that. So it will resend that frame. It won't, and the transmission proceeds to what do you say? You see the window is clubbed here. So it can proceed to the next frame rather than 2, 3, 4, all those things again retransmitted. Rather, you can move on to the frame after 3, that is here in this case it is 0. So that is much more, that is selective repeat. Only the frames which were damaged, which are lost, they are retransmitted. That is the thing. So this uses the concept of acknowledgement as well as negative acknowledgement frames. Only those frames for which the NAK is received, they are retransmitted. So this is the summary of the protocols, the flow control protocols in the data link layer. You have no protocol case, that is simple protocol, then stop and wait protocol, then go back in, and what is a selective repeat or selective reject. Both these cases are both names are there. Selective repeat is more commonly used, and so the best approach is selective repeat. So actually your TCP, transmission control protocol, uses the sliding window protocol for flow control. It does these things by use of sequence numbers. All those things we'll take up in the subsequent modules, but this is a very efficient way of doing the thing. And this is how your internet works. Your connection oriented protocols work. Your connection less protocols, they are not bothered about whether any thing is received or not. Say UDP. So I was watching a movie and between or watching a live stream, it's lost, means lost. That frame is lost. So it's classified as the best effort service. It will make the best effort to deliver that frame, best effort to deliver the packet. That is the connection oriented protocol. It still cannot ensure 100% reliability. That is the best effort service. You can say it is making the best effort to do that. So that brings us to the next function of the data link layer, which is called as error control. So any doubts in this data link layer flow control? Anyone has any doubts? Class ഉണ്ട്. So anyone has any doubts?
ഇല്ല.
അപ്പോൾ just take 5 more
minutes. നിസാം ഒരു ഡൗട്ട് ചോദിച്ചിട്ടുണ്ട്.
നിസാം പറയൂ. നിസാം ചോദിക്കൂ.
അല്ല എന്ന് വെച്ചാൽ വീഡിയോ കോൺഫറൻസിങ് ആൻഡ് ഗൂഗിൾ മീറ്റ് ഒക്കെ UDP ആണ്.
ടെലഗ്രാം പ്രോട്ടോകോൾ ആണ്, അതിന്റെ വേരിയൻസ് ആണ്. ഇപ്പൊ യൂട്യൂബ് എല്ലാം ഇതുപോലെ തന്നെ കണക്ഷൻ ലെസ് പ്രോട്ടോകോൾസ് ആണ്. It's a proprietary protocol of Google. So something called as RMTP, something like that. So these are proprietary. It's not open source. So there are different proprietary protocols following this each of these approaches. So TCP IP is an open source thing. It is available, it's known to everyone what is happening in that. There are different algorithms even for TCP, transmission control protocol. But different companies, they have come up with proprietary standards and protocols which are closed. That is what. So we are the people don't know what is the inner workings. That is what. So various reasons they have done that. Hope that clears. നിസാം എന്താ എവിടെ ഉണ്ടാ നിസാം
Yes, sir.
എന്താ
Okay.
ആരാണ്
ഉണ്ട് sir.
ആ ഡൗട്ട് ക്ലിയർ ആയോ അല്ലെങ്കിൽ ഇനി എന്തെങ്കിലും ചോദിക്കാനുണ്ടോ ഈ കാര്യത്തിൽ തന്നെ
Sir, അതുപോലെ വാട്സാപ്പ് അതിൽ TCP IP ഉപയോഗിക്കുന്നുണ്ടോ?
that I'm not aware of. It's a store and forward arrangement. It's a store and forward arrangement. It's an application layer software which uses um, say an approach, something like say I'll next day I'll share this WhatsApp, the structure, how it is, whatever we know of how it operates. But it's a sort of store and forward arrangement. Store and forward arrangement. It's a message switched network like arrangement.
സർ അതുപോലെ വീഡിയോ കോൺഫറൻസിങ് ചെയ്യുമ്പോൾ സെർവറുടെ അവിടെ പ്രസൻസ് ഉണ്ടോ, അല്ലെങ്കിൽ പിയർ ടു പിയർ ആണോ?
സെർവറിന്റെ അവിടെ
അവിടെ സാന്നിധ്യം ഉണ്ടോ? അവിടെ ശരിക്കും നമ്മൾ ഡാറ്റ ഫ്രം സെർവർ പിന്നെ അടുത്ത യൂസറിലോട്ടാണോ പോണത്, അല്ലെങ്കിൽ ഫ്രം ഡയറക്ട്ലി യൂസർ ടു യൂസർ ആണോ ഡാറ്റ
No, there
സെൻഡ്
would
ചെയ്യണത്?
be some, there would be an intermediate pathway which is coordinating all these video feeds. Otherwise, you can't ensure that all these feeds will get to the correct point. There will be something which is running in, say, for instance, for this Google Meet, there is something running there which is coordinating this Meet as well as all these users. So, so there will be something. It's a centralized process. It should be a centralized process. Otherwise, all of us will not be able to interact further. Maybe it is distributed as well. The control is distributed as well. We may not be connected
താങ്ക് യു.
through the same way, same server probably. It might have a distributed control as well. Fine. Okay. So let us
ഓക്കെ
come
സർ.
back to the presentation. I'll just start off with this error control thing. This is error. So this is noise. Noise is always there, and I had sent a message. This is the correct binary pattern corresponding to data networks. I converted it into bits, and I just changed one or two bits, and the entire message changed. You are not able to make out what is it. ഇത് actually generate ചെയ്തതാണ് കേട്ടോ. So this is actually generated from using this encoding. So 8-bit. So that is, I just use a representation like this. So this error is always there, and as of now with as of now you are aware that error, your channel does not make any difference, any distinction between say data, acknowledgement, nothing. For it, everything is bits, zeros and ones. It can randomly introduce errors, and communication is probabilistic communication. Probability theory has a lot of role in communication, and you are all electronics and communication engineers, and you are studying this what is it, digital communication. You would have come across these situations. Say it's all estimates, and your mobile phone is a device which makes use of all these probability theory, statistics, and estimates. Your signal that your mobile phone picks up from towers, how it makes the weak signals into intelligible speech. It's all marvels. Actually, it's a very marvelous device, your mobile phone. It's putting into use each and every principle of communication you have learned from your textbook. It is from sampling theory to the estimating the sound from background noise. All these theories are put to practice in the mobile phone. So you should be, even though we are using these gadgets now, all the theoretical basis for all these things were made years ago, decades, maybe 3 decades ago. The theoretical foundations were laid, and we are actually, and those people were not able to use these gadgets. That is the thing there. They contributed the theoretical basis, the mathematical basis for this, and we are enjoying the fruits of their efforts. That is to be appreciated. It's not, we take it for granted, the mobile phone, but it's a very marvelous invention, because the mobile phone power, the transmitted power and the received power, if you take consider, it's to order a few microwatts or milliwatts or few microwatts. From that, to make out a intelligible signal without zero errors, without any errors. You say through the phone pass and I hear as fail, means that doesn't happen in mobile phone. It works marvelously. That's what. So it's all probabilistic. So this are two ways. There is one is called as an error detection schemes, and there is error correction schemes. So we'll say error control is implemented both in the data link as well as transport layer. Say, and to detect errors, there are some mechanisms. To correct errors, there are some mechanisms. We'll discuss about bit errors and burst errors and all those things. Say, these are the things which we'll discuss. Say, these are some things which we'll discuss. So error detection schemes, some of which you are aware of, and error correction schemes are also there. The automatic repeat request, ARQ, that is go back in, as well as the selective reject, selective repeat. These are coming under error correction schemes. Broadly, if you speak, they are coming under error correction schemes. And the error correction codes, the convolution codes, the block codes, all those things. You will learn information security, and you call them as forward direction error correction codes. So that things we won't discuss in depth, but we'll just make a passing reference about them. But we'll discuss this detection schemes here. Correction schemes are not per se included in the syllabus. You will read study more about these things in information security. So the paper information security, I think it's offered as a elective paper. It's well and good to learn that. So now with this we wind up. I think Smita Miss has a class scheduled at 11 o'clock. So and I'll say next day we'll meet and continue with the